Everybody, and welcome to the first regular session. Of course, there are concurrent sessions, so one of the first regular sessions in AutoCarto. My name is Barry Kronenfeld from Eastern Illinois University, but I'm not speaking today. We have four wonderful speakers talking about inclusion in cartography and GI science. Our first speaker is actually my former student, Jason Yu, and he'll be talking about cartographic aspects of animated epidemiological dashboards.
Thank you. Okay, so my name is Jason Yu, and here's my former advisor, Dr. Barry Kronenfeld. Today, I'm going to talk about human subject experiments that we conducted about cartographic aspects of animated epidemiological dashboards. Today, we will talk about first background and motivation and research questions that we try to answer, and then survey methods, subjects, survey instrument, and then we will move to the survey questions. We have three parts. There's preliminary questions, main questions, and preference questions, and then analysis and result. So with the fast spread of COVID-19 pandemic, there were tons of COVID-19 dashboard, whether it's animated or static. There were tons, and I can say it really helped a lot, but not all the dashboard has sound cartographic design choices, and some of them has really questionable cartographic designs. For example, they were using wrong symbols or colors, and they're not considering population context, so on. And those dashboards can lead to misinterpretation of local disease levels and regional clusters and temporal trends. Therefore, we try to assess the advantages and disadvantages of various symbolizations and measure the importance of effective disease maps. Here are 7 questions that we try to answer. First 3 is about cartograms. First, whether prior instruction on cartogram influence accuracy, and we also test effectiveness of cartograms and maps, and whether cartogram help notice small but densely populated districts. And then we move on to the effectiveness of size and color, and whether number of districts, complex or complexity, and redundant symbolization help performance. And lastly, we ask participants whether what kind of maps they prefer and what type of animated maps they're most comfortable with. Okay, subjects. We recruit subjects from Prolific. It is easier and faster way to recruit subjects. And we had 2 rounds of survey. Each round, we recruit around 100 participants. And we had 2 requirements. First one is they need to be fluent in English, and we also require equal number of male and female participants. And we also screen the suspicious responses. For example, respondent who didn't answer some of the questions, or respondent who answered the preliminary map questions incorrectly. This is the screenshot of actual survey. This developed from scratch and using web technologies, for example, HTML, CSS, JavaScript. And this survey form was connected to Google Forms, and which automatically saves the participants' answer to the Google spreadsheet, which we didn't need to have the separate server to store the responses. And the middle part, we can embed the static and animated disease map. And also, as what I said before, we had 3 question sections, preliminary questions, main questions, and preference questions. And then 2 rounds of survey was conducted. In the preliminary questions, we in round one, we asked 3 questions about background knowledge about bubble maps, core plus maps, and cartograms. In round 2, we additionally asked a question about bubble cartograms, core plus cartograms, and colored bubble cartograms. Also, there were 7 additional questions about the interpretation of size of bubbles and size of district size to help subject understand the bubble cartogram. In the main questions, case data were developed for 100-day period for districts in 7 district regions. And we had 3 seed districts and then 2 outlier districts. In round 1, we have Canada, Iowa, Colorado, New York, Europe, and Western Europe. In round 2, we have Canada, Iowa, California, New York, and Europe. Subjects were asked to recall the location of the highest peak of the case rates during each 3 waves. In the preference questions, only subjects in round 2 were asked for the preference questions, and they need to choose one animated map form to view real USA data. And subject choices were based on 3 different purposes. First is visually clear and easy to interpret, and second one, best communicate case rates, and lastly, communicate case counts, rates, and population simultaneously. After viewing the USA animation, they were asked whether they are satisfied or dissatisfied with their choice and would like to pick another map. Each regions were designed to help answer each research questions, and responses were analyzed using 2 sample differences of proportions and binomial logistic regression for statistical testing. So for the result, we found that prior instruction on the size ratio facilitates the accurate interpretation of bubble cartograms. We also found that interaction effects between prior instruction and other map forms. For example, in Canada, there were positive interaction between cartograms, and in New York, there was negative interaction between colored bubble cartogram where district was densely populated. This suggests that prior instruction alerted the subjects to the fact that district with the largest bubble may not have the highest rate per population. And next we go to the effectiveness of cartogram versus map. Result depends on subjects' ability to infer case rates per population from the bubble cartogram correctly. Even though we have 94% accuracy rate for preliminary questions in a static environment, subject receiving bubble cartograms performed significantly worse than animated bubble maps in wave 2, which is Ontario was the correct answer. On the other hand, result for wave 3, correct answer was British Columbia. In round 2 suggests a small advantage for subject receiving bubble cartograms. Which means that subjects were strongly influenced by bubble size alone, even though the variable indicates case counts, not the case rates. And the advantage of bubble maps over bubble cartogram was strongest when the same district had both highest case counts and rates. We also found that cartogram reduced visual bias for large, sparsely populated districts. Subject presented with corpus cartograms more likely to correctly identify densely populated districts. On the other hand, 3 out of 4 waves, the district with peak rates was sparsely populated. Results suggest that higher accuracy for subject receiving the corpus map. And we move on to the effectiveness of size and color. Result didn't support the perceptual advantage for the either symbol, size, or color, and correctly identified the peak district for each wave with nearly the same frequency of regardless of the visual variable. However, in bubble map in wave 2 and 3 performed slightly better than the corpus map, weakly suggestive of possible perceptual advantage of size over color in context of animated web. And later, I will talk more about subject preference, and the people who receive the choose to see the corpus map for USA map wanted to change to the bubble map later. And then number of districts or map parent complexity also didn't influence the recall accuracy. And then however, for the wave 3, relative performance was highest for subjects receiving the map with fewer districts, suggestive of possible positive influence of number of districts on pattern recall ability. And I'm going to talk about redundant symbolization. And we found that redundant display of rates through both color and size ratio didn't enhance the pattern recall accuracy over the color alone. In round 1, without the prior instruction about the bubble cartograms, bubble sizes draws more attention than color. Subjects who received the color bubble cartogram were more likely to get correct districts when the district has the large bubble sizes, but less likely to get the correct answer when they have the district has the small bubbles. In round 2, with the prior instruction about the bubble cartograms, the correct district in wave 2 had large population, and subject receiving the color bubble cartogram performed worse. We found 2 reasons for this, and first one is many districts surging simultaneously and then overload the subject's visual perception. And second one was the prior instruction increased subjects' cognitive loads such that they fail to infer the correct information from the large number of data points. Lastly, we will talk about what type of animated map are people most comfortable with and why. As we can see here, 59 people out of 107 chose corpus map for visually clear and easy to interpret, and 43 out of 107 chose corpus map for best communicating case rates, and 70 out of 106 participants chose colored bubble cartogram for communicating case counts, rates, and population simultaneously. And their final choice for the USA map was 50 for corpus, 12 for bubble, 6 for bubble cartogram, 7 for corpus cartogram, and 30 for colored bubble cartogram. We also asked why the participant chose the map version over other versions, and we analyzed into 2 types. First one is aesthetic consideration, and second one was data. The aesthetic consideration, we analyzed the keywords such as simple, easy, pleasant, clear, and then for the data, we analyze the keywords such as data, information, or like specific data variables such as case rates or population. And the selection of the bubble map was most closely associated with the aesthetic consideration. And then colored bubble cartogram were most likely to indicate consideration of data variable. And among 81 subjects who expressed the satisfaction or dissatisfaction with their selection, the highest dissatisfaction rate was for the corpus map. And also the qualitative feedback suggests the preference of bubble size over the color as a visual variable. For example, total of Among the participants, 25 subjects who choose the animated map form using color but not size. 8 expressed the desire to switch to the different map form that include the size as a visual variable. In contrast, none of the 12 subjects who chose an animated map form using size but not color was not desired to switch the map form to other ones. For the key takeaways, I can say subject accuracy rate are affected by prior instruction, symbolization, map forms, and depends on subject population and number of districts. And also, cartograms effectively draw attention to more densely populated regions regardless of accuracy. And we also found that subjects prefer size when they ask preference questions. And lastly, etymological dashboards should carefully consider map forms and symbolizations. Our final work is under review in Cartography and Geographic Information Society in a special issue on visualization techniques in context of COVID-19. And here are contact information for both of us. Thank you.
Can you hear me? Oh, there we go. Thank you, Jason. And we have a few minutes for questions. So are there any questions for Jason, myself?
Cool. Thank you very much for that presentation. Just a kind of very general question. What's your kind of next steps from now? What's the kind of next things you might investigate?
Well,
so a big question.
I'm looking at my advisor.
He's looking at me because he's moved on to University of Nebraska,
Yes.
Lincoln, and he's going to be working on different projects. But my next steps, I think we have some tantalizing hints that are things that might be going on here, but we didn't get statistical significance. Like it seems like people's attention are really drawn to bubbles more than colors when you have them both. It seems like cartograms draw attention to population, but sometimes that lowers accuracy rather than increases. So I just want to follow up on those things. So those are my next steps. Yep. Any other questions? We could probably take one more. Or if not, we will move on to our next speakers. Thank you, Jason.
Thank you.